of the day. Myself, Revathy Gopinath, Assistant Professor, Department of Electrical and Electronics Engineering, Madanapalli Institute of Technology and Science. Today I am going to explain you about superposition theorem and how we are going to do the problem. So here I have written the definition. It states that in any linear network containing two or more sources, the resulting current in any branch is the algebraic sum of the current that would be produced by the individual sources acting alone while the other sources are non-operative. So here I will explain you this definition by solving one problem. So here we have two voltage sources, that is first one is 10 volt and second one is 20 voltage source. And here I want to find current flowing through 3 kilo ohm by applying superposition theorem. So here first, so I'm going to explain you the first step. So step 1, by considering 10 voltage source. So first I want to consider 10 voltage source. So according to the theorem, it is clear that if you are considering one source, then that another source should be non-operative. So here I am going to redraw the circuit again by considering the 10 voltage source. So that time, and another thing here we want to know, that is when you are considering first source, that time 20 voltage source should be short circuit. So that is the thing. If it is a voltage source, we will short circuit it, and if it is a current source, we will open circuit it. So here first I am considering 10 voltage source and I am going to redraw the circuit. So this time I short circuited this path. So again here 10 volt, this is 1 kilo ohm, this is 3 kilo ohm, this is 2 kilo ohm. So now what we want to do is we want to find current flowing through 3 kilo ohm. So here only one voltage source we have, and here this current, let it be I1, I want to find I1. I1 is the current flowing through 3 kilo ohm when 10 voltage source is acting. So how to find I1? So here we need to find I1. So here to find I1 we can simply apply current division rule and we can find I1. So to apply current division rule, we know we can apply, we need to write total current into, we need to write 2 opposite resistor by sum of resistor, that means 2 plus 3. So we want to know the total current. So if you want to find total current, then we want to know the effective resistance. So here it is 10 volt, we need to find effective resistance. So if you want to find effective resistance, we know it is clear that 2 and 3 connected in parallel, which is in series with the 1 kilo ohm. So here effective resistance will be 2 into 3 divided by 2 plus 3, because these two are connected in parallel, which is in series with the 1. So you will get 2.2 ampere. So 2.2 milliampere. So this is the current, total current of this circuit. So here we can write total voltage, it is 10 volt, 10 divided by 2.2. So here we will get I1 as IT as 4.54 milliampere. So 4.54 milliampere, it is the current. Sorry, this is cut. This is 2.2 ohm. And here total current is equal to voltage divided by effective resistance. So voltage will be 10 volt, 10 divided by 2.2. That is the effective resistance. So here you will get total current as 4.54 milliampere. So now if you know the total current, then here you can find total cut So total current, it is 4.54 milliampere. So if you know the total current, then here we can substitute and we can find the I1. So here I am writing, so I1 will be, so here first we are finding the total current. Total current we can find by dividing voltage divided by effective resistance. So effective resistance, here it is clear that 2 and 3 connected in parallel, which is in series with the 1 kilo ohm. So here we are getting 2.2 kilo ohm. So this is the effective resistance of this circuit. Next, we can so that we are dividing voltage divided by effective resistance. So you are getting 4.54 milliampere. So this is the total current. Next, we can apply current division rule. So here I1 is the current flowing through 3 kilo ohm. So that will be equal to total current into opposite resistor, that is this one, divided by sum of resistors. So here you will get I1 as 1.816 milliampere. So I1 is the current flowing through 3 kilo ohm, that's equal to 1.816 milliampere. So this is the current when your 10 voltage source is acting. The same way, now what we are going to do is we will consider 20 voltage source. The same way we will find how much is the current flowing through 3 kilo ohm. So this is the first step. Then in step 2, now I am going to consider 20 voltage source. So that time this 10 voltage source we will short circuit it. So our circuit will become, so this is 1, this is 3 and this is 2. So in this case also we will find how much is the current flowing through these 3. So here also the same way we will follow, we will apply current division rule and we will find current flowing through this 3 kilo ohm. So here also first here cut. So here I3 will be equal to, I3 is the current flowing through this 3 kilo ohm. So that will be equal to total current into here 1 divided by 3 plus 1. So here also first we need to find the total current. So here total current will be equal to, this is 20 volt. So 20 divided by effective resistance. So first we need to find the effective resistance. So here if you want to find the effective resistance, here it is clear that 1 and 3 connected in parallel, which is in series with the 2. So we know 1 into 3 divided by 1 plus 3 plus 2. So here we will get 2.75 ohm, 2.75 kilo ohm. So that is the effective resistance of the circuit. So here now next step we can find total current. Total current is equal to 20 divided by 2.75. So here the total current will be cut. So here total current will be 20 divided by 2.75. So that will be equal to 7.27 milliampere. So this is the total current of this circuit. Next here again we are applying current division rule. So I3 will be equal to 7.27 into 1 divided by 4. Cut. So here you will get 1.81 milliampere. So that here finally, so here I3 is the current flowing through the 3 kilo ohm when 20 voltage source is acting. So according to the superposition theorem, here we have written, if you want to find a current in any branch, then it will be equal to algebraic sum of the current that would be produced by the individual sources acting alone while the other sources are non-operative. That means if you want to find the current flowing through 3 kilo ohm by superposition theorem, then finally we need to add this both currents. That means the current I1 plus this current. So here I1, here already we got I1 as 1.816 plus this current we will add, cut. So here we have to add both the current, that is the current flowing through 3 kilo ohm when 10 voltage source is acting, plus this current, current flowing through 3 kilo ohm when 20 voltage source is acting. So that will be the final answer. So again we will do another problem. So in this problem, so this is the second problem. So in this problem, we want to find current flowing through 8 kilo ohm by applying superposition theorem. So here we have two sources. One is 20 volt and another is a 2 ampere source. So here also we are going to apply superposition theorem to find current flowing through 8 kilo ohm. So to find first, so here we know step 1. Step 1 is we will consider 20 voltage source. So that time this is a current source, so we need to open circuit it. So here this 20 ampere, this current source we will open circuit it. So again I am going to redraw the circuit. So here this is 20 voltage source. This is 2 kilo ohm, 8 kilo ohm, and this is 4 kilo ohm. So this is open circuit, means here we can draw like this. So this is 2 kilo ohm, this is 8 kilo ohm, and this is 4 kilo ohm. So this is 20 voltage source. So here by considering 20 voltage source, we will find the current flowing through 8 kilo ohm. So first step is we are finding this current, let it be I1. So here if you want to find current flowing through 8 kilo ohm, then we need to apply, we do not cut. So here in this step we need to find current I1. I1 is the current flowing through 8 kilo ohm. So here we can find I1 by dividing voltage divided by resistance. So voltage it is 20 volt divided by resistance. So here resistance it is 2 plus 8, that is 10. So here you will get 2 milliampere. So 2 milliampere is the current flowing through 8 kilo ohm when 20 voltage source is active. So this is the first step. So we found I1 when 20 voltage source is acting. Next we need to consider 2 ampere source. Here we are going to find the current flowing through 8 kilo ohm when 2 ampere source is acting. So again we will redraw the circuit, and here we know in this time we will short circuit the voltage source. So I am going to redraw the circuit. So here this thing I short circuited, then this 2 kilo ohm, 8 kilo ohm and 4 kilo ohm. So this is 2 kilo ohm, 8 kilo ohm and 4 kilo ohm, and this is 2 ampere source. So here also we need to find the current flowing through 8 kilo ohm, let it be I2. So here only the way here we can apply current division rule and we can find the current flowing through 8 kilo ohm. So here current flowing through 8 kilo ohm, that will be equal to total current into this 2 divided by 2 plus 8. So here total current, here current source is itself they have given, so we so the total current of the circuit it will be 2 ampere itself. So I can write 2 into 2 divided by 10. So 4 by 10. So here you will get 0.4 milliampere. So 0.4 milliampere is the current flowing through 8 kilo ohm when your 2 ampere source is acting. And according to the superposition theorem, we have to add these two currents. Then you will get the current flowing through 8 kilo ohm. So the final answer will be current flowing through 8 kilo ohm will be equal to I1 plus I2. So I1 will be 2 plus I2 will be 0.4. So here you will get 2.4 milliampere. So 2.4 milliampere is the current flowing through 8 kilo ohm. So I will explain this problem once more. So here the question is we need to find current flowing through 8 kilo ohm by applying superposition theorem. So here we have two sources. One source is voltage source and another is a current source. So this is 20 volt and 2 ampere. So here if you want to apply superposition theorem, we have to find separately. So first we are considering 20 voltage source. That time 2 ampere source we will open circuit it. So that is the first step. Here we are open circuiting this path, and here we will find how much is the current flowing through 8 kilo ohm when your 20 voltage source is acting. So here just we will divide voltage divided by resistance. So here 20 divided by here total resistance is 2 plus 8. Here it doesn't have any meaning, so we are not considering this path. Here it is already open circuited. So 20 divided by 10, so here you are getting 2 milliampere. So this is the I1 is equal to 20 divided by 10. So you are getting 2 milliampere. So this is the total current of the circuit, the same current flowing through 8 kilo ohm. So we got I1. Next, we will consider 2 ampere source. So that time here only way we can apply current division rule to find current flowing through 8 kilo ohm. So here current flowing through 8 will be equal to total current into this resistor divided by sum of resistors. So here total current it is 2 ampere itself. So 2 into 2 divided by 2 plus 8. So here we are getting 0.4 milliampere. So finally we can add this I1 plus I2, that will be the current flowing through 8 kilo ohm by applying superposition theorem. Here first turn I am doing it again. So here I'm going to explain this theorem with one problem. So here the question is we need to find current flowing through this 3 kilo ohm by applying superposition theorem. So here we know if you want to apply superposition theorem, you want to consider one source at a time. That time other source should be non-operative. It is already written here. Other source should be non-operative. So here first I am going to consider this 10 voltage source. So first step is we are going to consider 10 voltage source. That time this 20 voltage source we have to short circuit it. So again I'm going to redraw the circuit. So here this 10 voltage source. So this time this should be short circuit. So this is 10 voltage source, this is 1 kilo ohm, this is 3 kilo ohm and this is 2 kilo ohm. So here let it be I1. I1 is the current flowing through 3 kilo ohm. So our aim is to find this I1. So to find I1, here I am going to apply current division rule. So here the equation will be I1 is equal to, so let it be IT. IT is the total current of the circuit. Total current into this resistor divided by sum of resistor, that is 5. So here we want to find the total current IT. So to find IT, that will be equal to voltage divided by effective resistance. So our aim is to find effective resistance. Now, so to find effective resistance, here it is clear that 2 and 3 connected in parallel, which is in series with the 1 kilo ohm. So you can write 2 into 3 divided by 2 plus 3, which is in series with the 1 kilo ohm. So here you will get 2.2 kilo ohm. So 2.2 kilo ohm is the effective resistance. So here we know if when two resistors are connected in parallel, equation is R1 R2 by R1 plus R2. So that equation only here I applied and it is connected in series. So we are adding like plus 1. So here you are getting 2.2 kilo ohm. Now you can find total current, that is 10 divided by 2.2 kilo ohm. So the total current will be 4.54 milliampere. So 4.54 milliampere is the total current of this circuit. Now you can apply this thing in this equation. So I1 will be equal to 4.54 into 2 divided by 5. So it will be equal to 1.816 milliampere. So 1.816 milliampere is the current flowing through 3 kilo ohm when your 10 voltage source is acting. So this is the first step. So I will explain this first step once more. Here we are considering 10 voltage source and here our aim is to find current flowing through this 3 kilo ohm. So let it be I1. I1 is the current flowing through 3 kilo ohm right now. So we need to find I1. So if you want to find I1, then we can apply current division rule. So here this is the equation. So here total current into this resistor divided by sum of resistor. So here first if you want to apply current division rule, you want to know the value of total current. So total current we can find by dividing voltage divided by effective resistance. So first we need to find the effective resistance. That means here 2 and 3 connected in parallel, which is in series with the 1. So effective resistance will be 2.2 kilo ohm. Then we can put this in this equation. You will get total current of the circuit, and this value we can substitute here. You will get this I1. I1 means current flowing through 3 kilo ohm. So this is the first step. Next we have to consider 20 voltage source. That time 10 voltage source should be short circuit. So that is the step 2. Step 2, I am considering 20 voltage 20 voltage source. So again we are redrawing the circuit. So that time this should be short circuit. So now this will be our circuit. So here also we need to find current flowing through 3 kilo ohm. So let it be I2. I2 is the current flowing through 3 kilo ohm. So here we need to find I2. So here also the same method we will follow. We will apply current division rule to find current flowing through 3 kilo ohm. So here I2 will be equal to total current into this 1 divided by 3 plus 1, that is equal to 4. So here first we need to find total current. So if you want to find total current, that will be equal to, this is 20 voltage source, 20 divided by effective resistance. So here we know 1 and 3 connected in parallel, which is in series with the 2. So first step is we will find effective resistance. That means 1 into 3 divided by 1 plus 3 plus 2. So your effective resistance will be 2.75 kilo ohm. So effective resistance, it is 2.75 kilo ohm in this case. Then we will find total current, that will be equal to 20 divided by 2.75. So here you will get 7.25 milliampere. So 7.25 milliampere is the total current of the circuit. Next you can find I2. I2 will be equal to, here we can apply. So total current is 7.25 into 1 divided by 4. So here you will get 1.81 milliampere. So I2 is the I2, it is equal to 1.81. That is the current flowing through this 3 kilo ohm when your 20 voltage source is acting. So according to this superposition theorem, we need to add this I1 and I2. Here we have written algebraic sum. It is the algebraic sum of the current that would be produced by the individual sources acting alone while the other sources are non-operative. So here we got I1 as 1.816 milliampere and I2 as 1.81. So final answer will be current flowing through 3 kilo ohm will be equal to I1 plus I2. So that will be equal to 3.62 milliampere. So 3.62 milliampere is the final current. So this is one example for superposition theorem. So here we have two voltage sources. So first we will consider one source at a time, and we will find a current flowing through 3 kilo ohm. Then we will consider 20 voltage source. Then we will find current flowing through 3 kilo ohm. Then finally we will add these two things. You will get the final answer. So this is one example for superposition theorem. So thank you.